Total internal reflection. When a ray of light travels from a denser medium to a rarer medium, the reflected ray bends away from the normal. The angle of refraction is greater than the angle of incidence. As the angle of incidence increases, the angle of refraction also increases. For a particular angle of incidence, the refracted ray just grazes the surface of separation. The angle of refraction is 90 degrees. This corresponding angle of incidence is called the critical angle C. Critical angle. When a ray of light travels from a denser medium to a rarer medium, the angle of incidence in the denser medium for which the refracted ray just grazes the surface of separation is called the critical angle. When the angle of incidence in the denser medium is increased greater than the critical angle, the light ray gets totally reflected back into the same denser medium. This phenomenon is called total internal reflection. Conditions required for total internal reflection. 1. The ray of light must travel from a denser medium to a rarer medium. 2. The angle of incidence must be greater than the critical angle. Astronomical telescopes. Astronomical telescope is used to view heavenly bodies like stars, moon, planets, etc., and focus an inverted and virtual image with wide field of view. When the image of distant object is formed at D, to trace the path of the rays through the lenses, consider the rays coming from the top of a distant object. As the object is far off, the ray from its top falls upon the lens as a parallel beam inclined to the principal axis and after refraction gets converted to the point A on its focal plane at a distance FO from objective. Therefore, a real inverted image of distant object is formed at AB due to objective. The eyepiece is placed at a distance less than FE dash focal length of eyepiece. A ray from A parallel to principal axis passes through FE dash and other through C2 goes straight. The two rays appear to diverge from A dash. Thus, the virtual magnified image of definitions connected with lenses. Optical center. Optical center of a lens is a point on its principal axis such that a ray whose refracted path within the lens passes through this point has its emergent ray parallel to the incident ray. In case of thin and symmetrical lenses, whose radii of both sides are equal in magnitude, the optical center lies at the center of the lens. Principal axis. Principal axis of a lens is a line passing through the optical center of the lens and perpendicular to both the faces of the lens. Principal focus. In case of convex lens, principal focus is a point on the other side of the lens where a beam of light parallel to principal axis before refraction meets. In case of concave lens, principal focus is a point on the principal axis from where a beam of light parallel to principal axis before refraction appears to diverge. Focal length. The distance between the optical center and principal focus is called focus or focal length. Structure of eye. The eye consists of a nearly spherical ball of about 2.5 centimeters diameter. Its outermost coating is made of a tough and opaque white substance known as sclerotic. It preserves the shape of the eye and protects it against external injury. The front portion of sclerotic is transparent and is slightly bulged outwards and is known as cornea. There is a layer of black tissue below sclerotic and is called choroids. It serves to absorb any stray light and thus avoids blurring of the image by reflection from the eyeball. In front of eye, choroids merge into a colored diaphragm known as iris, with a hole in the middle called pupil. When we refer to the color of eyes of a person, we refer to the color of iris of the person. The pupil corresponds to the stop in the camera. It regulates the amount of light entering the eye. In strong light, the pupil contracts so as to admit less light, whereas in dim light it expands so as to admit as much light as required. Behind iris is a crystalline lens, the curvature of whose front face is considerably less than the back face. It is made of large number of jelly-like layers whose density increases towards the middle. The lens is held in position with the help of ciliary muscles. The lens divides the eyeball into two chambers, the front chamber called anterior chamber and the other between lens and the retina is called posterior chamber. Anterior chamber is filled with a fluid called aqueous humor, while the posterior chamber is filled with a jelly-like substance called vitreous humor. The innermost coating of the eye, covering the rear of inner surface, is a very delicate membrane called the retina. It is richly supplied with blood vessels and nerve fibers and serves as light-sensitive screen to receive the image. The sensation of the vision in retina is carried to the brain by a nerve called optical nerve. The most sensitive part of retina is known as the yellow spot. It is a slightly raised portion with a slight depression known as the fovea centralis. The point where the optic nerve enters the eye is totally insensitive to light and is known as the blind spot. Formation of images. Object at infinity. The image is at the principal focus, real, diminished, inverted. Object beyond 2f. Image is between f and 2f. Real, diminished, inverted. Object at 2f. Image is at 2f. Real, same size as the object. inverted. Object between f and 2f. Image is beyond 2f, real, magnified, inverted. Object at f. Image is at infinity, real, magnified, inverted. Object between f and o. Image is on the same side as the object, virtual, magnified, erect. Object anywhere in front of the lens. Image is on the same side, virtual, diminished, erect. Long-sightedness or hypermetropia. A long-sighted person can see distant objects clearly, but cannot see distinctly objects lying closer than a certain distance. Causes of the defect. This defect is due to either the size of the eyeball becoming too short, the lens becoming too thin, so that its focal length becomes abnormally large. Normal eye. It is able to focus the rays from normal near point 25 centimeters from eyes. Defective eye. Due to eyeball getting short or decrease in focal length, the rays do not focus on retina. Defective eye is able to form image at the retina when object is moved from N to N dash, the near point of defective eye. Corrected eye, a convex or and convergent lens of suitable focal length, converges the rays to match those coming from N dash. Light. Light is a form of energy. The natural source of light energy is the sun. Light travels with the velocity of 3 into 10 power of 8 miles per second, requires no medium for propagation. Light can travel liquids through some solids and gases. It can also travel through vacuum. The various properties of light are rectilinear propagation of light, reflection, refraction, dispersion, total internal reflection. Laws of refraction. The incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. The ratio of the angle of incidence to the sine of angle of refraction is a constant for any two media for the same color of light. This constant is called the refractive index and is generally denoted by I, sines, and it is also known as Snell's law. Mu is equal to sine angle of I by sine angle of R. Lenses. Lens is a portion of a transparent refracting medium which is bounded by two coaxial spherical surfaces. The different types of lenses are convergent or convex lenses, divergent or concave lenses, convergent or convex lenses. Convergent or convex lenses are thicker in the middle than at the edges. These lenses bend the rays towards the center of the lens. They are further divided into three categories. Double convex lens. Both surfaces of this type of lens are bulging out. It is also called convex lens or biconvex lens. Plano-convex lens. One of the surfaces of this type of lens is plane and other bulging out. Concavo-convex lens. One of the surfaces of this type of lens is concave and the other convex radius of concave side is more than that of convex side. It should be noted that all convex lenses are convergent lenses, but all convergent lenses are not convex. Divergent or concave lenses. These are thin at the center and thick near the edges. They bend the rays towards the edges of the lens. They are also further divided into three categories. Double concave lens. Both surfaces of this type of lens are bulging inwards. It is also called concave lens or biconcave lens. Plano-concave lens. One of the surfaces of this type of lens is plane and other concave. Convexo-concave lens. One of the surfaces of this type of lens is convex and the other concave. The radius of concave side is less than that of convex side. Mirages. Mirages are optical illusions formed due to total internal reflection of light. It takes place when light rays travel from one layer of air to another layer of air of varying densities due to differences in temperature. Hot weather mirage. In deserts, during the daytime, the layers of air near the Earth's surface get heated up quickly and become less dense than the other layers of air above. Less dense layers of air get trapped between the ground and the more dense colder layers of air. As a result, the light rays from the top of an object undergo total internal reflection and appears to form an inverted image in water for a distant observer. Cold weather mirage. In Arctic regions during winter, mirages are formed over the sea in the sky. The layers of air close to the Earth are cooler, denser, and sink below. The layers of air above are warmer and less dense. Light rays from the heads of the object, that is the ship, are totally reflected downward, forming an inverted image above the object in the sky. Short-sightedness or myopia. Normal eye, far point at infinity. Rays from distant object meet at retina. Defective eye. Eyeball is enlarged. Cannot focus rays from infinity at focus. Defective eye. Far point is nearer than infinity when at far point F the image is formed on retina. Corrected eye. Concave or any divergent lens diverges the parallel rays from infinity to an extent that they appear to diverge from F. They get focused at retina. Optical instrument. Photographic camera. Photographic camera is a device used to obtain a permanent image of an object on light-sensitive photographic film or plate. Principle: when an object is placed beyond 2f of a converging convex lens, it gives real, inverted, and diminished image between f and 2f on the other side of the lens. Construction: it consists of a metal box painted dull black on inside to avoid internal reflection and to make it light tight. The chamber is fitted in front with a leather bellow B, and its length can be changed with rack and pinion arrangement. In front of bellows, a convex lens is fitted. Shutter. An adjustable shutter called the diaphragm is provided behind the lens system. It serves two purposes. It regulates the aperture of the lens, thereby adjusting the amount of light passing through it. It decreases the effective aperture of the lens, thereby reducing the spherical aberration and improving the definition of the image. F numbers. The diameter of the aperture bears a definite relation with focal length of the lens. The value of f by d are generally marked on the cameras as 4, 5.6, 8, 11.3, 16, 22.6, etc. The aperture 4 means that the diameter of opening is f by 4. Refraction of light. When a ray of light travels from one medium to another medium of varying optical densities, the direction of the light ray gets changed at the surface of separation of the two media. This bending of light ray is known as refraction. Terms and definition relevant to the refraction of light. Normal. The perpendicular drawn at the point of incidence to the surface of separation is called the normal. The incident ray. The ray of light traveling in the first medium is called incident ray. The refracted ray. The ray of light traveling in the second medium is called the refracted ray. Point of incidence. The point at which the incident ray strikes the refracting surface is called the point of incidence, the angle of incidence. The angle between the incident ray and the normal is called the angle of incidence, I. The angle of refraction. The angle between the refracted ray and the normal is called the angle of refraction, R. Refractive Index. I is constant, which is the refractive index of the second medium with respect to the first medium. If the first medium is air or vacuum, then the ratio sin I divided by sin R is set to the refractive index of the second medium. For all transparent solids and liquids, I is greater than 1. The refractive index of water is 1.33 and crown glass is 1.52 respectively. When light travels from medium A to medium B, the ratio of the sine of the angle of incidence in A to the sine of the angle of refraction in B is called the refractive index of the medium B with respect to the medium A. AIB is equal to sin I divided by sin R. If the path of the ray is reversed, R becomes the angle of incidence and I the angle of refraction. Then the refractive index of medium A with respect to medium B is given by BIA is equal to sin R divided by sin I. Evidently, AIB is equal to 1 divided by BIA. Simple microscope or magnifying glass. When an object is placed in front of a convex lens at a distance less than the focal length, then we get a magnified image of the object on the same side. If the lens is placed at such a distance that the final image is formed at the least distance of distinct vision. Now, triangles A-B-C and ABC are similar. Therefore, A-B- by AB is equal to CB- by CB. Minus H2 by H1 is equal to minus V by plus U, or H2 by H1 is equal to V by U, or M is equal to V by U. Again, 1 by F is equal to 1 by U plus 1 by V. Here, V is equal to minus D. Therefore, 1 by F is equal to 1 by U minus 1 by D, or D by F is equal to D by U minus D by D is equal to M minus 1, or M is equal to 1 plus D by F. Magnifying glass is used by palmists to interpret lines on the hand. Magnifying glass is used by watch repairers to magnify different parts of watches. Compound microscope. It consists of two convex lenses placed coaxially within a sliding tube. Lens O, called objective, is towards object. It has a small aperture and short focal length. The lens E through which the final image is seen is called the eyepiece. The eyepiece and objective are fitted in a sliding tube. The tube as a whole can be moved in or out to see the image of the object clearly. To draw the course of rays, the rules used are same as used in case of convex lens. A ray from A of object AB going parallel to principal axis passes through principal focus F on the other side of objective. Another ray through optical center C1 goes straight. The two meet at A dash, giving the inverted image of AB at A dash B dash. Again, eyepiece is placed in such a way that B dash C2 is less than FE dash, the focal length of eyepiece. Again, a parallel ray from A dash passes through FE dash, the principal focus of eyepiece, and a ray through C2 goes straight. The two appear to meet at A dash dash when produced backwards, giving the final image of AB at A dash dash B dash dash. The sliding tube is adjusted in such a way that A dash dash B dash dash is at least distance of distinct vision. The magnification of microscope is the ratio of the size of the image to the size of the object. The magnification is given by M is equal to L by FO, square bracket begins, FE plus D by FE, square bracket ends, where D is the distance of distinct vision, that is 25 centimeters for normal eye, L the length of microscope tube, FE and FO dash the focal lengths of eyepiece and objective respectively. These days, microscopes up to magnifications of 5,000 or even more are available.